Hello students, I'm going to show you how to simplify a few expressions that have both positive and negative exponents. Now there are several ways that you can approach these problems, but the method I like to use is first of all take care of anything that has parentheses. I want to start by simplifying those expressions first, or those pieces of those expressions first. To do this, I'm going to apply what we call the power rule. The power rule is that exponent rule that states that if you have a base a raised to a power n, all of that raised to a power m, then that's equivalent to having your base raised to a product of the powers. In other words, a to the n, all to the m, is equal to a to the n times m. Do you remember that rule? So let's see how this can be applied to simplify or begin to simplify our expression. Let's take a look. I have x to the 6th, y to the 2nd raised to the 4th power. Applying the power rule, I would have the following. X to the 6th to the 4th, I would multiply 6 times 4 and get 24. So that's just x to the 24th. Y to the 2nd to the 4th, again I would multiply my powers, and that would give me y to the 8th. Now over here I likewise can apply the power rule. I have two factors, x and y cubed. Now x is like x to the 1st power, right? So if I have x to the 1st power to the negative 3rd power and I applied the power rule, I would be taking 1 times negative 3, so I will get x to the negative 3. Y to the 3rd to the negative 3 is equivalent to y to the negative 9th power. 3 times negative 3 is negative 9. Now that's all divided by x to the 5th, y to the 2nd. By applying the power rule, I've made my expression just a little simpler than what we started with. Well, again, next there are a couple different things that you can do. One thing that I like to do is I like to get rid of any negative exponents that I have. I like to deal with those right away. So I'm going to take the two expressions that have negative exponents and I'm going to apply the rule for negative exponents right here. The negative exponent rule tells us that any base raised to a negative exponent is equivalent to 1 over that base raised to the positive exponent. What the negative exponent rule allows us to do is it allows us to take these negative exponents and convert them into positive exponents by simply taking the base and moving it from the numerator to the denominator. So let's go ahead and look at our expression. We have x to the 24th, y to the 8th, and we have two x to the negative 3rd and y to the negative 9th that are both negative exponents. So we need to move these bases to the denominator and make those exponents positive. Again, some people may choose to do a different rule to simplify at this point, but this is the thing that I like to do second, no matter what kind of expression I'm looking at. I like to keep things in order. So I'm going to take that x to the negative 3 and move it down to the denominator and make it x to the positive 3. And I'm going to take y to the negative 9th and bring it down to the denominator and make it y to the positive 9th. All right, so now what we're going to do is apply two final rules. Those two rules are the rules to apply when you have two bases are the same and you want to combine the exponents. Do you remember that rule? So if I have x to the 5th and x cubed next to each other on the same level, and I want to combine those exponents, if I have two like bases, I'm going to add the exponents. This is known as the product rule. And the product rule states that any value a raised to a power n times a raised to the power m is equivalent to a raised to the m plus n. Let's apply that down here on the denominator. We have on the top x to the 24th, y to the 8th. And on the bottom, we have x to the 5th, y to the 2nd, x cubed, y to the 9th. I'm going to put together my like bases of x. X to the 5th times x to the 3rd is x to the 5 plus 3, which is just 8. We'll do the same thing with the y's. Y to the second times y to the ninth. They have like bases, so we add the exponents, and that gives us y to the 11th. All right, we are almost finished. Notice there's one last thing we can do. We have a variable x here and a variable x here. We can simplify and combine these two exponential expressions, again, because they have like bases. But this time, they're not being multiplied. The bases are not being multiplied. Instead, they're being divided. So the rule we need this time is the quotient rule. The quotient rule tells us that if we have a base a raised to a power n divided by a base a raised to the power m, we can combine those bases by subtracting the exponents. So that's equal to a to the n minus m. Applying this rule here, let's take our expression, and we have x to the 24th over x to the 8th. Subtract the exponents, 24 minus 8, and that gives us x to the 16th power. Let's put the y's together. Y to the 8th over y to the 11th. Now notice this time, the 8 is smaller than the 11. So if we take 8 minus 11, we'll get the power -3, which isn't good. But what you can do to get around this fact is subtract the other way. If the power is bigger on the bottom, then subtract 11 minus 8, which is 3, but the answer has to remain on the denominator, on the bottom, because that's where the larger exponent was to start. So x to the 24th over x to the 8th is equivalent to x to the 16th. Y to the 8th over y to the 11th is equivalent to 1 over y cubed. And this expression that we started with simply simplifies down to the final answer of x to the 16th, all divided by y cubed. And we're finished.